Good morning, guys. Today we're going to talk about section 7.4, solving equations containing radical expressions. To solve an equation that has a radical expression, we have to eliminate the radical symbol. In order to do that, we need to isolate that radical expression on one side and raise both sides to the appropriate power. For example, if you have the square root of x equals 2, what is understood to be under here is a 2. That also is x to the 1/2 power. What can we raise both sides to that would eliminate this 1/2? Power to a power you multiply. So what would make that 1/2? 1/2 times what is 1? So it's going to be 2. So you always raise the power of whatever root is happening. So this is a square root, so we are raising both sides of the equation, the second power, so our answer would be x equals 4. This process can produce some extraneous roots. So we have to make sure that whenever we get an answer, we plug it back in and check to make sure it is not extraneous. So let's plug 4 back into the original. The square root of x equals 2. The square root of 4. Does that equal 2? 2 equals 2. Yes, it checks out. So let's look at some examples. All right. The square root of x minus 7 equals 8. It's a square root again. In order to solve this, we are going to square both sides. X minus 7 equals 64. Add 7 to both sides. X equals 71. Let's check. The square root of 71 minus 7, the square root of 64, and that is 8, so we are good to go. All right, next example here. We have to first isolate our cubed root. It's a cube root this time. We have to make note of that. So, first step, subtract 1 on both sides. The cube root of 3x plus 2 equals -4. Check. If that was the square root equals negative, we could stop right there and say no solution. However, this is a cube root, so in order to get rid of the cube root, we are cubing both sides. So the cube root of 3x plus 2, the cube root of 4, so the cube root of -4, 64. That process eliminated the cube root. I don't need that anymore. Subtract 2. Divide by 3. X equals -22. It checks out. So -22 is the correct answer here. All right, last example here. The square root of 2x plus 13 equals x plus 5. The square root is isolated. So when we square both sides, what do we have to do here on the right-hand side that we haven't had to before? We have to FOIL. Perfect square trinomial. Now we have an x squared term. We have to move everything to one side and set equal to 0. Factor. X equals -2. Go ahead and check both of these and see if they are both valid answers. All right, so on the left here, I plugged in -6. When we do that, we get the square root of 1 equals -1. That is not the case because the square root of 1 is +1. So that would mean -6 is an extraneous answer. -2 up here. The square root of 2 times -2 plus 13. Does that equal -2 plus 5? It's the square root of 9 is 3. 3 equals 3, so -2 is the correct answer. So always check, because sometimes the process of solving radical equations results in extraneous answers. So we have to make sure we check them and cross them out.